In this video, I'll be talking about ionic radius. Before I actually get into the video, I wanted to let you know that I appreciate your feedback on these videos and that it's good that you're telling me what I'm doing wrong or what you like or what you don't like so I can improve on it. Some of the things I've been told are that I have a messy handwriting, I'm a fast talker, and I have a very thick accent, and I'll try to improve on those. I guess I'll definitely talk slower, and I'll try to write a little clearer, but I don't know what I can do about my accent. I, I wasn't really born in the US, so English is not my first language, if you didn't tell before. But I'll try my best to talk slower and write clear. So if you have any complaints, any issues, if you don't understand because of something I'm doing, make sure to tell me so I can improve on it. The point of this video is to help you learn these concepts, and if there's something I'm doing that isn't helping you learn the concepts, please let me know. So as I said before, we'll be talking about ionic radius today. Well, as its name states, it is just the radius of an ion. We talked about atomic radius in previous videos. Now, the ionic radius is a little different. And what we're measuring is the distance between the nucleus and the electrons. So it's forming like a radius. This is a radius. And well, this is our atom, or in this case, ion. And because we have two types of ions, we have one that's positively charged and one that's negatively charged, we'll have two types of radius. We will have a cationic radius and an anionic radius. And just to refresh your memories, this is a positive ion, this is a negative ion. So I'm going to start by talking about the cationic radius. So when we look at an element like sodium, we have a positively charged nucleus and then the electrons orbiting in those orbitals. So this orbitals would have an overall negative charge and the nucleus an overall positive charge. But when we talk about ions, like something like Na+, the sodium ion, this plus means that this molecule is electron deficient. I have to improve that. I'm sorry. Deficient. So it doesn't have as many electrons as it would have in its atomic form. So that means we have an overall, we have more positive. You can just consider that positive as having more positive here. So I'm just going to write two plus signs just because it has one here. And when the nucleus is more positive, what that's doing, it's attracting those electrons more into the nucleus. There's more force to attract the electrons inside. So let's say this is a sodium atom. It's that size. When it's in its ionic form, so Na+, the size would shrink because that electron deficiency will make the attractive force stronger. The positive nucleus will pull those electrons better if it doesn't have as many electrons fighting it. So the ionic radius decreases 4 cations. So that's our first ionic radius trend. When you have a cation, a positively charged ion, the ionic radius will decrease. Now the other type of radius for an ion is the anionic radius. So it's a negatively charged particle. And applying the same logic, if you have more electrons, you can just consider Cl, that's the atom. If you have, like, it would go to 2Cl minus. If you have this negative sign here, means that this molecule is electron rich. It has more electrons that it would usually possess in its atomic form. So we will have more electrons here trying to repel each other. So this nucleus, the positive force, won't be able to attract them, because you can just consider it weaker because the negative charge is stronger. So those electrons will want to stay as far apart from each other as they could. So they will just expand the size of the ion. So if your Cl atom was like this, you have to. It was a Cl2 before, because that's how it goes in nature. Then it would just become, as you can see in the formula, 2 different bigger anions. So for our trend, ionic radius, increases for anions. So now let's apply it for different type of for different ions. And I'll have to draw, and I'll probably be told that I don't know how to draw, because I mean that is true, but I'll try my best. So let's say we have lithium, magnesium, chlorine, and sulfur. This is plus. So we said for cations the radius will decrease because of the stronger attractive force, and the more positive it is, the stronger that force will be, making the radius smaller. So for lithium, it only has one positive, so it will be smaller than it usually was. But for magnesium, because it has 2 positive charge, then it will be smaller than lithium. So G2 plus is smaller than Li plus. Then for ions like chlorine and sulfur, the ionic radius will increase because of a stronger repulsive force. So chlorine only has 1 negative charge, so it will be a little bit, but bigger than the lithium. And then the sulfur has 2 negative charges, so it will be the biggest radius. So to arrange it, we would say that magnesium is the smallest and sulfur is the biggest. So magnesium is smaller than alpha, which is smaller than chlorine, which is smaller than sulfur. So as you can see, if the charge is positive or the most positive, that ion will have the smallest ionic radius. And if the charge is the most negative, it will have the biggest ionic radius. And that's it for ionic radius. If you found the video helpful, like it and share it with your friends.